When you experience an eclipse, you feel that connection with space.
Oh my gosh!
Oh, look at the ray structure!
The universe is out there and it's affecting us. We are in space.
And here it comes, there's the diamond ring. And that is the most spectacular sight.
If you haven't seen it, you haven't seen anything.
Good morning. Before we get started, we were supposed to have the Federal Highway Administrator, Shailene Batt, with us this morning. You've probably seen the emergency that's happening in Baltimore. Our thoughts are certainly with them. Our prayers are with the people and the families involved. I've often said that at NASA, our mission is for all humanity, and that's because space brings us together. There's no better proof than moments like this, a total solar eclipse. It's a moment when millions of people across North America will look to the heavens as the moon passes in front and between the sun and the earth. And it's a rare sight that we haven't seen in 7 years. And unusual things start to happen as the normal rhythms of Earth are disrupted. When you're seeing this eclipse, you ought to observe this. As the day appears to turn to dusk and then dark, people have heard birds stop singing. They've seen giraffes suddenly begin to gallop, roosters start crowing, and crickets chirp. So watch for these unusual behaviors. And we encourage you to help NASA observe the sights and sounds around you. Eclipses have a special power. They move people to feel a kind of reverence for the beauty of our universe. Their power is not only to unify us on Earth, but to further science and discovery. In 1919, Albert Einstein's theory of gravitational bending was proven when scientists measured how stars shift when the sun is blocked out by the moon. And today, over a century later, a total solar eclipse still brings great opportunity in science. Safety is always NASA's #1 priority, and that remains true for this solar eclipse. Make sure you have the proper eye protection, like the eclipse glasses. And as you look at the heavens on April the 8th, when the eclipse starts, please, please put those glasses on.
Remember the first time that I learned that this is, it's kind of a very rare thing that it just so happens that our moon is at the right size and distance to cause this effect here on Earth. And I hope that the awe that you were talking about, sir, is completely, understood by everybody who gets to experience it, because it's really a miracle of our universe. The thing that's so unique about a solar eclipse is that it's an opportunity to look at 3 celestial bodies, the Earth, the Moon, and the Sun, in entirely different ways than we usually do. And our scientists are going to take full advantage of this celestial event to get invaluable data. One focal point is definitely the sun's atmosphere, or the corona. So this is a very elusive region, and it can be viewed during a solar eclipse in a very special way. It's key to understanding fundamental questions about how heat and energy are transferred out into the solar wind, which contributes to our understanding not just of solar dynamics, but also how solar flares and the solar wind will affect life here on Earth. Things are happening with the corona that we don't fully understand, and the eclipse gives us a unique opportunity to collect data that may give insights into the future of our star. And it just so happens we're at solar maximum. So the chance we're going to see something amazing is very high.
The video here shows the moon's shadow from the annular eclipse in October. NOAA and its partners at the North Carolina Institute of Climate Studies also provided this interactive map, which shows the climatological percentage of clear sky during the eclipse at all these different locations to help people plan their viewing experience. Once the eclipse is over, NOAA and NASA will continue preparing for the upcoming launch of the GOES-U satellite, scheduled for June 25th. It will carry the nation's first operational coronagraph, which is a solar telescope that blocks the disk of the sun. With this powerful instrument, we will see the fainter outer atmosphere of the sun, called the corona, where extreme space weather events originate. An additional coronagraph will be on the Swiffle-Lagrange 1, also known as Swiffle L1, observatory, which is scheduled to launch next year in 2025. This NOAA satellite will be stationed 1 million miles from Earth and positioned toward the sun, where it will act as an upstream buoy, capturing data from incoming space weather events. Both of these coronagraphs will give us an unprecedented view of the sun. But what you may not know is that in a total eclipse, we see the corona in a way that not even coronagraphs can fully capture. This is why we call it nature's coronagraph. We look forward to getting this unique inside look from nature on the types of measurements we need on a continuous basis for space weather forecasts and warnings. Thank you.
In addition to our over 20 satellites in NASA's Heliophysics System Observatory that regularly observe the sun, we'll be using rockets, planes, and balloons and on-the-ground observations to optimize the science return of the eclipse. As the previous speakers mentioned, the sun and its effect on the Earth, called space weather, is one of the motivating factors in our study of the sun. And although the focus will be on our sun's corona, or outer hot atmosphere, as the moon blocks the bright disk of the sun, the eclipse also gives us the unique opportunity to research our Earth's reaction to that sudden loss of sunshine. So starting with our Eclipse rocket experiment, APAP is a series of 3 rockets launched from Wallops Flight Facility to explore the layers of the Earth's atmosphere called the ionosphere. So again, that layer is important as it's the one that our communication signals pass through. Disturbances in this layer can cause issues with GPS and communications. The series of rockets will sample the layer of the atmosphere to see how it changes with that sudden day-night change of the eclipse, and that information can be fed into models for us to better understand the Earth's atmosphere. NASA's WB-57 plane, with 2 solar experiments and 1 atmospheric experiment aboard, will chase the eclipse, getting an additional 2 minutes of totality and deeper understanding of the sun and the Earth's atmosphere. So dozens of student teams will launch balloons along the eclipse path before, during, and after the eclipse to get measurements of the Earth's atmosphere. In addition, a NASA team will be using a balloon to study the weather of the eclipse.
Well, I don't know about you, but I remember where I was during the last total solar eclipse, and I'm really excited about this one, and I didn't even understand all the science. Nikki Fox will probably hold me accountable for that. So I'm sorry, I think the wrong remarks are up. Thank you so much for joining us here today. I appreciate the opportunity to kind of share with you some of the things to be safe about, and I join the administrator in the condolences to everyone affected. During the eclipse, we want to make sure that we're not relying on our standard lights on our cars. We want to make sure that we're looking out for the pedestrians. Please don't just stop on the side of the road. It's really important to make sure that we stay focused on everyone around us. People are probably going to be stopping, so be careful.
Today's conference, you may now disconnect at this time. Have a wonderful day.
Totality right on through. So we're going to start this from the United States at 1:27 in the afternoon. This is the 3D path of totality now on April 8th. If you're in it, this is going to be a really cool perspective on when you need to make sure that you're ready to go in. Get out there early. I'm sure every one of these cities are going to have a ton of people coming to visit. There is 1:27 Central Time into the afternoon. This is starting to come back into the United States now. So places like San Antonio, Austin, heads up. We're going to roll this forward here. We're going across the entire country into parts of Canada, so this might take a minute, so bear with me. Stick around. I want to make sure everybody's included. There's 1:33 in the afternoon over San Antonio on the north end of town, so if you're on the south end of town, you might need to do just a little bit of traveling. Austin, we're going to be up, though, in totality. There's 1:36 into the afternoon. Waco, we're going to be up. Same for us in Fort Worth. This is going to be 1:41 now in the afternoon. This is all local time. Texarkana, we're closer to 1:45. This is pausing this at 1:48. Fort Smith, Arkansas, we are not in totality, but the south side is. You don't have to go far to get in there. Hot Springs, Little Rock, Conway, what's going on, guys? We are in totality. This is at 1:53 in the afternoon. Memphis, we are not in totality. Don't have to go far, though. I had to take a trip up to Jonesboro. We're going to be in totality at about 1:56 in the afternoon. Now, getting into Paducah, we're going to see that as well. We're in totality. Terre Haute, about 3:05, we're going to be in that time frame, just after 3 o'clock. Bloomington into Indianapolis, the bigger cities of Indiana, we're going to be in totality at about 3:07. Muncie, we're up just after that. Columbus, Ohio, north side of town, this is just skirting us. You're going to be in it. South side, you might need to just take a little drive on the north side of town, and you'll be able to be in totality. Into Rush Creek, Findlay, Ohio, Crane, Ohio, Mansfield, we're going to be up just after 3:11 into the afternoon. Now, we're pushing into 3:15. We're back into Eastern time again. This is all local. Akron, Ohio, Cleveland, Ohio, Ashtabula, we are in totality at 3:15. Heads up, Erie, Pennsylvania, Buffalo, New York. We are in totality just after 3:15. We're pausing this at 3:18. Rochester, Syracuse, we're coming up. Syracuse at 3:23. This continues for us into Watertown as well. We are right smack dab in the middle of totality. Going to be a great eclipse for us, weather permitting anyway. Keeping our fingers crossed that everybody gets it. Middlebury, Vermont, shout out. Same for us in Burlington, Plattsburgh, New York, into North Elba. We are in totality at 3:27 in the afternoon. Montreal, we are in it as well at that time. All right, we're up in Maine, into Lincoln, into Pine Knoll, Presque Isle, 3:32, and then Presque Isle just after that, we get in there, and then this works its way into New Brunswick at about 4:35 AST. Again, this is all local time now, so I wanted to give you that perspective.